Hello YouTube, De-bodgery here. So I've done it. I have taken apart a brand spanking new BAC8000 ASI controller. These are truly field-oriented control, unlike the KO Pro and probably the rest of the KO product line, which are not. Or if they are, they've got a very, very basic field-oriented control feature set in them. But anyway, yeah, here it is apart, and yeah, that was fun. The hardest thing was getting the Mosfets loose. So inside, the Mosfets are held down by these two steel kind of spring clips. So here's the other one. This one was fairly loose. When I say loose, I mean I could push it out the end of the slot in the heat spreader and free the one side. This one, however, not the case. It was in there really good, and I basically had to pry it up and bugger up a lot of the Mosfets around it and things like that. But once I had this one out, I was able to kind of work things loose, and that made things a lot easier. So the cover here, so you've got UV and W, that's your three phases, battery plus, battery minus. This is reasonably nice molding work. Again, I think it's just ABS. It's got a date stamp on the plastic over here, which says it's got 6/22, so that would make June 2022 is how I read that. But again, there's no markings in here as far as what the plastic is. And let me try cutting it with my knife. Yeah, it doesn't crunch or anything, so it's probably just ABS. But yeah, it's reasonably precision molded. I don't really have any problems with the quality of the molding work. Yeah, that's reasonably good. The end caps, get to all this, you know, that's the secret sauce, right? The end caps were not doing anything to hold down the orange cover. They literally have nothing to do with holding that on at all. They have screws that go in here. You know, this one's the same way. But that holds them in place, but it doesn't have anything to do with the lid. The lid itself, the only thing that was holding it on, really, was all of the potting. So on the underside here, you can see these four little studs. Yeah, they sunk down, and of course these did too, down into the potting, and that was pretty much it. You know, prying this up was super easy. It didn't take much effort at all. And here, let me turn this over. So here's the heat spreader, and it's sitting there. You know, it comes right up, no problem. So, and yes, I did bleed for you. That's my blood on there. So yeah, the orange cover is only held in place by potting, and the only thing that keeps it from sliding back and forth is the end caps. Otherwise, it doesn't interlock with them or in any way. It's kind of an interesting design. This was completely free-floating, separate from the end caps. But hey, you know, it had potting on it, so you know, around these four studs and around there, so it wasn't really going anywhere. The heat spreader is kind of cool. I mean, it's a pretty good size mass of aluminum, so I'm sure it does its job pretty well. I don't really have a problem with it, but you know, if you're really running this controller at full wattage, I'm pretty darn sure you've got to put this on a heatsink of some kind so that it can radiate away, because otherwise this smooth surface isn't really going to do a particularly good job, because there's got no fins on it, so it doesn't have any real way to radiate heat all that well. Probably like a water block or a big heat sink, or mount this on some larger metal object is going to do the trick. Inside these steel strips, they go inside slots like that, and they drop right in right now because there's no pressure on them. But when they are lifted up with Mosfets underneath them, well, they don't come out so easy. They are in there pretty good. This one was pretty easy to drive out. I was able to drive it out the end, and it just basically slid right out after I got it part way out. And so that side came out easy. This side, however, as you can see, it's kind of bent and warped because, well, I had to work at that one. That one would not budge. It was in there really good. With the way KO does, or sorry, the way ASI does this is once they have everything all assembled, they have these things sitting on top of the Mosfets, and then they have some kind of a blade, sort of a machine that pushes down on here, and it shoves these steel strips down into those slots in the heat spreader. And once they're in there, they're locked in there. They are not coming out. Yeah, that was not easy getting these things, or that one, get this other one out. Anyway, yeah, there is no way you're going to repair an ASI controller, not without damaging it worse, which I would have to say is definitely the case. Maybe ASI has some trick for it, but yeah, I have taken many things apart and not destroyed them in the process. And this was not one of those times. Yeah, I've had a lot of experience fixing, repairing electronics over the years, and this was by far one of the things that after a while I went, you know what, there is literally no chance that I'm going to pull this thing apart without damaging it severely. And so, yeah, I broke it worse than what it ever would have been if it was blown up. So, nice solid beefy heatsink, but yeah, no serviceable repairable parts inside because damn, you can't get at them. Yeah, nice heatsink. So, here is some of the bigger pieces of potting and other things. So the Mosfets were stuck down on this piece of Kapton, and the other one, which was under the side that was really stuck down, that one's kind of mangled. This one's still in pretty good shape. Kind of wish that the Kapton was a little bit thicker, because Kapton is really fragile stuff, and it tears super easy. So, yeah, takes almost nothing to tear it. It's very, very fragile stuff. Very heat tolerant, but very fragile. The Mosfets and everything else were buried in potting, like you can see here. That's where all the Mosfets were on that side, and you know, here's the other side. It came away from the Mosfets pretty nicely. But yeah, the potting was literally everywhere, and that's good as far as thermal conductivity is concerned, because these things are going to, this potting is going to pull heat away from everything really, really well. Which is going to help cool the controller and help it radiate to its shell. So that's a good thing in a big way. This, I'd have to say, when it comes to repairability, this is a nightmare from hell, and ASI never wants you to work on their controllers ever. So yeah, I didn't much care for that, but obviously it works, it's reliable, and they don't care about you working on their stuff, they just care about their controllers not breaking down. So yeah, they definitely got that part. There's a lot of pieces of potting that came up with, you know, circuitry pattern on and stuff like that that turned out kind of interesting. All right, let's talk about this little guy right here. So this is the brains of the operation on this little daughter board. And on the main board, it used to be mounted right here. This little row of pins, I was not able to unsolder those, which is what I really wanted to do. And this set over here, I was. So yeah, these ones here ended up just taking my X-Acto knife and just cutting through all the pins because they're fairly thin. And these ones here, I was able to get them to migrate out with a hot soldering iron, so those ones are still all intact. Okay, on the top side of the board here, you have a Bluetooth module. I don't like this. I don't know why they did this. It's kind of weird, odd, bizarre, strange. So you can see all these little traces right here, of which they only needed 4, and they've got all these solder pads on here. So why did they wire it? Why didn't they just solder it down directly? It's the same damn thing. There's literally no pinout difference here than there is here, but they didn't. They put it on these 4 little wires, and yeah, that's kind of weird. And the point of that was, I don't know. It was wrapped in this little piece of Kapton. But yeah, that's strange. I saw that almost immediately once I had the cover off and thought, okay, really, really bizarre. Here's another thing that I don't understand. There is silicone on here, silicone caulk, and it's around this little LED right here. And I think they did that so that the potting wouldn't flow around that LED and blind it, because in the lid you do have a little light pipe right here, and that's for showing status. So I think they put that silicone around there just so the potting wouldn't flow over top of that LED, because, well, this is opaque. And yeah, anyway, I think that's what that was about. Anyway, you've got a little DC to DC converter on here. I don't know what that little chip is, but yeah, that's your DC converter right there, and I'm sure it's a buck. You know, this thing is 100 volt max, so that's probably dropping to down like 12 volts or something like that is my guess. Don't really know. Can't find out, right? Because I had to destroy the controller to get the thing out. Yeah, there is a bunch of little pins all across here that go to stuff. Don't know what exactly. And of course, there's also these 2 rows of pins over here as well. On the other side, you have a TMS 320. It's a TI chip. Does a lot of the same sorts of functionality as, say, like an STM32, but it's TI's implementation. There's an LM22901. Yeah, that's what it looks like to me. And I don't know what that one says. It's some other TI chip. Let me get out some magnifier. See if I can't read it. There we go. It's a 1BCXRRK. Yeah. Don't know what that is. I have to look up the parts. And then there's a smaller chip down here. This little guy, this is a 7805, which is a 5-volt regulator. Probably these components need 5 volts, hence the little 5-volt regulator. There is another little inductor over here. So there's probably a third DC to DC on this board, or a second DC to DC, I guess. I can tell you that the TMS 320 needs 3.3 volts, and probably this little Bluetooth module does too. So probably some of that has to do with that. I don't see anywhere on here a 3.3 volt linear regulator. However, right there, there is a little chip. Let's see, does that say anything on it? Nope, that is not. That's looks like a little Mosfet. So, yeah, this is probably a Mosfet, not a linear regulator. It doesn't have a part number that I recognize as a regulator chip. So anyway, probably you've got maybe this guy right here is doing the 3.3 volts. Probably. I mean, it is over right on top of where the CPU is and right next to the Bluetooth module, so that kind of makes sense. And you may not even have 12 volts here at all, which is not all that unusual. You don't necessarily need it if you don't need it. So anyway, there is no MOSFET drivers on here. This is basically CPU and Bluetooth, and that's about it. You know, and a couple DC to DCs. So anyway, on to this. Yeah, bunch of junk. Right? Yeah, lots and lots of potting. So that was good. There is little chance that you're going to have heat build up inside this controller with all this very thermally conductive potting. You know, I hold it in my hand, and like this piece right here, it's very cool in my hand, and the reason why is because it conducts heat away. So, you know, it's doing its job. I would say they definitely picked a good potting formula for that. Right here, I believe, this little guy, let me flip this over so make it kind of right side up, if you will. I believe this guy right here is your MOSFET driver. And then on the board in different places, like right here is one, and there's a few more of them on here. I've seen them. Yeah, there's one right there. There's another one. Yeah, I believe that those guys are probably the actual drivers for the MOSFETs, but I don't know that for sure because I haven't had a chance to look at the controller. Literally had it apart long enough to make a video. So anyway, I think that's video 1, and I will do more of a deep dive on this in a second video.